Hey guys, welcome to episode 3, video 4 of the state tree tutorial series. This episode is going to be a little bit different because we're going to be looking at how Unreal has set up their own state tree for the AI that they made. I believe it's for the arena shooter variant for the first person template. Because of the material we're covering, it's going to be less edited than the previous episodes and more of just a live stream kind of thing. Consider this to be more like a lecture, so if you need to watch this on 2x speed, feel free to do so. In the last few episodes, we actually finished up the state tree system and we got everything done, so if you haven't watched those yet, feel free to watch those first. Watching those will give you a really good understanding of the material we cover here, but other than that, let's go ahead and jump right into it. Hey guys, welcome back to a post-tutorial sort of discussion episode, or a review episode kind of, on not our AI, but how Unreal did their own AI. I'll be using this to kind of showcase how Unreal set everything up, as well as drawing some comparisons between how I like to do things and show how Unreal did things, just to emphasize that there's no right or wrong way to work with state trees. It's just whatever fits your understanding as well as your project best. So I'm actually opening up our project because even in our version of the project, we do have Unreal state tree system there. What I can do is I can go ahead and open up the content drawer. And if I go to variant shooter, I go to blueprints. And if I go to AI, I will see two state trees here. So this is the first thing that is the big difference between what we're doing and what Unreal's doing, is that Unreal is taking almost every element of an AI, and whenever it's using states, it divides that up into a state tree. I'll show how that works in just a second. So let's open up ST Shooter first. So this is what it looks like. As you can see, they also did something similar to what we did, which is they have color coding for their different states. One thing you'll notice down here is they have what's known as default, and it's default versus armed versus dead. So if we're dead, and this uses the enter condition system, which I briefly touched on last episode near the end, but we didn't really use it for our use case. But for enter conditions, it's evaluating this statement right here. If actor.current HP is less than or equal to 0. An actor is this right here. So in the BP shooter NPC, they're checking the current HP value. And if it's saying if it's less than or equal to 0.00, we're just going to go ahead and return true. So we can set that up by going to add new, and they're using a float compare. And so they're binding this input float to actor, let's see, current HP, and they're saying, hey, if it's equal to 00, and we can even change this to less than or equal to, and this kind of gives us the same statement as that. Now you'll notice that right now, for the first one is always going to be if, and the next one's going to be and. So which means both of these have to be true in order for it to enter here. But I believe we can click on this and change this to an or, which means either of these has to be true in order to enter into this state right here. So right now I'm gonna go ahead and remove this and delete this. But that's the dead state. The tasks here are just to delay for a second and to essentially have the debug text of dead. After this, it'll go to tree succeeded. So if it runs tree succeeded, which means we're basically done with the state tree, we can finish it, we're good to go. The tree has ended. Cease all logic in the tree. We're good. We have no longer any need for this. So actually, we have some transition logic in the root. So on trigger, we transition to dead if the actor's HP is 0. And so whenever we go back up to root, we're always checking to see every frame if this actor is dead or not. And because all of these states are child states of the root, we're basically checking to see if the actor is dead every single game frame, regardless of what state we're in. So that's good, which means that even if you're in the armed states or even in the default state, if the actor dies at any point in time, it'll go ahead and go to dead immediately. And this is an example of the on tick. We never used on tick, but we ended up using an event system, whereas for Unreal, for actually this situation, it makes a lot of sense to use on tick. Now, if there was an event where the BP shooter NPC essentially had logic inside of it, checked to see if its health ever went below 0, and fired off a state tree event, then we could set this to on event, listen to that event, and immediately go to dead. But I think the idea for this state tree setup was to keep as much of the logic inside of the state tree as possible, which is why they had the tick logic here checking every single game frame. So this is the dead state and the root state. Now we have the armed state. You notice that the armed state doesn't have any enter conditions or any selection utility. We go to root. Root has try select children in order, which means it'll always try to select from top down. So it's because dead can only be accessed as a state if the current HP is below 0 or equal to 0. It'll automatically skip this if the actor is alive and immediately go into the armed states. Alright, so here we have a couple different things we can take a look at. So let's go and close these and take a look at these individually. So for attack enemy, we have a couple different things. You'll notice we have a lot of symbols here. Don't worry about it just yet. We'll actually get into these. You can actually hover your mouse over it to see if what these mean. So the question mark is state selection is guarded with enter conditions, which means this has enter conditions that need to be true in order to select the state. You have this arrow, it's pointing downwards, which means when state is considered for selection, try to select the first child state in the order they appear in the list. If no child states are present, it behaves like a select state. So, not too sure why that arrow is there, but that's interesting. Oh, yeah, so this arrow is present here as well. So it's basically showing the selection, try select children in order. If I change this to select at random, it'll go ahead and change that arrow as well. This is just the name, and so this is the description, which is find locations with a clean line of sight to the target while running a parallel state tree to handle shooting. I'm gonna show how that works in just a second. It's showing that this task contains at least one task that ticks at runtime, and also it ticks at runtime while evaluating transitions. So this will show you that it has a task on runtime, and this will show you that there is a transition on it that uses on tick. Cool. Okay, so we have a couple things here. We have a few enter conditions in attack enemy. And so if state tree task sense enemies, has target is true, that's when we go ahead and the object is valid, and the object in this sense would be a target enemy. So if the target enemy is true, and if we have a target, we're gonna go ahead and go into this state right here. So state tree task sense enemies is actually a global task that is running, that has reference to the AI controller, the actor, has a sense tag and a direct line of sight cone angle, so this is the actual angle they're using, as well as a target enemy, investigate location, etc, etc. This is what's actually keeping track of all of the various elements that you can see kind of here that the other states will be using. And you again notice that the data in the parameters isn't necessarily data that is going to be changing consistently as the state tree is running. It's more of a set it and forget it type of system, whereas the data here is data that we can bind to and data that is changing. So if I go into the state tree task, you have on perception updated, which is a custom event, and you can see that they're essentially on the enter state, we're getting the transition results if we've changed to here willingly. So you'll see this a lot. This basically means that if, let's see. So if it was changed, then the state was just activated. Because there are different types of changes. A change type sustained means the current state was reselected to be the next state, whereas changed means that it was activated and it's a new state. It's not being reselected and rerun. So we're getting the AI perception and we're actually binding to those events, the on perception updated and on perception forgotten. And then here we are unbinding from those events on the exit state. So these events right here, we're saying, does the sense actor have the right tag? How do we successfully sense it? So this is the sense tag that we're looking for. So we're looking for the player tag. If the actor we sensed has this tag, if that's true, and if we've successfully sensed that actor, we check if we have direct line of sight to the stimulus. And I believe this is a custom function. Yeah, right here. But here they're doing a bunch of math to see if they have direct line of sight. They're doing a line trace from where they are to see if there's maybe a wall blocking them or something along those lines. Let me go back to the event graph. So if we have direct line of sight, if that's true, we're going to go ahead and set the target enemy. And we're going to go ahead and check has target is true, which is, as you'll notice, is the Boolean variable here and is the object we're checking for here. So if either of these are true, it's going to go ahead and go into this state immediately. Otherwise, arm state, which is, again, trying to select all these children in order, will say, hey, this isn't true yet. Let's go ahead and see if we can investigate a location. So this checks to see if we have a investigate location we can select, and the, let's see, output. Go ahead and find references. Cool. So here, what we're doing is we're saying, hey, if we have not successfully selected this, essentially, if we don't have direct line of sight, we're going to go ahead and go to here. So if you already have a direct target, ignore the partial stimulus and keep an eye on the target. So it's going to go ahead and if it's valid, if the target enemy is valid, we're going to go ahead and move forward. Otherwise, if we can actually check to the stimulus strength and see if it's stronger than the previous stimulus that we received. If it isn't, or sorry, if it is stronger, we can invest the stimulus location instead and go from there. So essentially the way it's working is it's saying, hey, if we received a new stimulus after finding the player, and this new stimulus is somehow stronger than the actual player target we had access to, whether that be because we've lost line of sight or because we haven't successfully sensed it, then what we can do is we can go ahead and set an investigate location and try to find that location. And it's using these two variables to go ahead and determine that. And this variable is kind of what we're looking for here as well. If this Boolean variable, the has investigate location, is true in the global task, it'll try doing the investigate location state as well, state instead. However, if both of these fail, if we don't know if we don't have a player to attack, or we don't have an investigate location to search for, we immediately just go to search for enemy, which essentially has like a debug searching, and it kind of just sits here. It doesn't really do too much. If the condition of the state tree task, if this Boolean variable is true, and we're checking again on tick, if this Boolean variable becomes true, we go to attack enemy. Whereas if this Boolean variable, I believe, if this Boolean variable becomes true, we go to investigate location. So you can again see that the order matters. So we're selecting the most important state at the top, then the second most important state, and then last but not least, the catch state, which essentially tries to transition itself to the other two states above it. And this is basically the entire logic. This is all there is to it. Now you have other things underneath it. For example, in the attack enemy, we have find sniping location, we have move to sniping location, and then we're waiting. Now it's using EQS, which is Entity Query System. This is a whole other system that Unreal has of not only letting an AI read the environment, but really understand what's happening in the environment. It's really powerful, and there are a lot of other tutorials that really explain it. In our situation, we're not really going to get into it too much, but you can see that these child tasks really only have at most one task in them. And this is kind of what I was talking about earlier, where in our state tree, we essentially kind of did something similar, where we had almost one task in each state. Aside from tasks that output data, we mostly just had one task per state. And this is kind of how Unreal's organizing it as well. So you can kind of see it here. You can see it doing its own thing. And so for the attack enemy, we find the sniping location. Again, this is from an EQS query, which means it's querying the environment, trying to find an ideal location. And then it's going to go ahead and move to that location. So what it's doing is so this is actually interesting. In a lot of the forum posts that I've seen, a lot of the times we're told not to really have the parameters be continuously modified by the state itself. However, it is important to note that Unreal is doing something different. What it's doing is it's essentially using this, whatever this asset may be, to find a good location for the entity query system and trying to get an output location. And it's actually setting that value here. It's changing this target move location value during runtime, which is really interesting. I did not realize that they actually would change their own parameters. But this is not a, I guess this is not, but I guess this is not a wrong way of doing this. I personally would have done it by making a global task called a data store and then keeping track of this variable there, but it's totally fine to do this as well. Again, the parameter, and adding variables to the parameter and making them not change is more of a personal choice rather than a choice that the engine kind of restricts onto you. Realistically, you can have all of these be parameter values and have the global task essentially make these parameter values that it edits during runtime. You can do that if you'd like. There's nothing wrong with that. Feel free if that's what's more comfortable to you. It's just a way of organizing data a little bit differently so that whoever is working with the state tree understands what's going on. But in this case, they're actually modifying the parameter. And we're able to use the parameter to actually move to wherever we need to go to. I might have done this a little bit differently. I either would have made this target move location into a global task, or I would have moved the move to task directly onto this find sniping location state. But in the interest of keeping these states and keeping the tasks separated via states, this is what they went with, and I think that's totally valid. So they wait here for a bit, for about a second with a 0.75 second random deviation. And after they move to the sniping location, that seems to be kind of it, as far as we're aware. Aha, so one more thing that I want to point out is in the attack enemy state, you can see that while this movement is going on, we're actually, we're facing a certain actor, which is the target enemy, and we're also running a parallel state tree. Let's go ahead and take a look at the shoot at target. And this is what I was talking about earlier by saying that Unreal essentially took every part of the enemy AI that might have been a state and just made it into its own state machine. So this is the shoot at target. This specifically controls the shooting logic. So this ST shooter controls the movement logic as well as the chasing and all that. This controls the shooting logic. So you can see that if we're attacking, if we have line of sight to target, and you'll notice that it's checking the parameters line of sight, it's checking all these variables, and it's also checking target. And right now target is set to none. What's interesting is we can set a parameter by clicking here on target and setting the parameter through the parent state tree. So if you run a state tree in parallel and you decide to run it from another state tree, you can set the parameters beforehand before you run it. So that's what they're doing here. They're setting the target, and if we have line of sight target, so it's actually checking, I believe this is a custom condition, and you can make new conditions by clicking here and clicking on state tree condition base. But we can actually take a look at this. Yeah, so this is the description, and we can actually see in the event graph, or sorry, it's received test condition. This is where they have all their logic to essentially check to see if we can shoot at the player or shoot at the target enemy. And once we have line of sight and all these values are fulfilled, it's going to go ahead and it's going to go here. Otherwise, it'll go to no line of sight, where it'll just delay for a bit, and we'll just be sitting here for a little while, and it'll go to root. And now what it's doing, and here's the interesting part, if we're in no line of sight, we're delaying for a little bit the line of sight check interval. This is to ensure that we're not checking every single game frame. But after this is done, we're going back to the root, and if we still don't have line of sight, it'll just keep running this continuously. So this is how to essentially limit how many game frames you're checking something, because bear in mind, running a check on almost anything is computationally expensive, and if you can find ways like this to delay it and to do it not every single game frame, but possibly every few seconds or maybe every second or so. In this case, we're doing a line of sight check interval at every 0.75 of a second. If you can find ways to delay it, what that's going to do is that's going to speed up your logic, and it's going to make everything run faster. So that way your state tree isn't checking everything every single game frame and polluting up your essentially one frame of logic. So if we're attacking, if essentially it'll only enter this if we have line of sight to target, it'll try selecting the children in order, so it'll try selecting shooting first. It'll calculate a random float between 1 and 3 on enter, and it'll delay it by this value right here. So then we shoot at the target while the state is active. So essentially, we find this target, and I think we can actually take a look at this. Let's see if there's anything else that I'm missing. Yeah, so we have start shooting. Now, important to note, this shooting logic is actually on the shooter NPC. So this isn't on the state tree. This isn't doing its logic here. It's doing this logic and it's calling this function on the state tree itself. So, sorry, it's calling this logic on the actor here itself, the BP shooter NPC. So we have that, and after that we do debug shooting. We have 2 transitions here. Which is on tick. If we lose line of sight, if has no line of sight target, then what we'll do is we're immediately going to transition to no line of sight, and we'll keep doing our delayed checks. Otherwise, we have another transition, which is once this is done, once we've completed this, and you can kind of see, I believe, that this has a... Let me go back here. Interesting. So once any of these is done, it's going to go ahead and go into the reloading, right? And so here's what's interesting. The shoot target while a state is active task does not have a finished task, which means according to the state tree, this task never finishes. However, we're checking for essentially the first task to be done, and that will always be this delay task. So essentially what we're saying is it'll either keep shooting for 1 second, for anywhere between 1 second to 3 seconds, and once that delay is done, this state is finished and we're immediately going to reloading. So that's the way they're doing like a variable amount of attack time essentially, which means this enemy will either shoot for 1 second, for 2 seconds, or for 3 seconds. Actually, I think it's, yeah, 1, 2, or 3, and then after that's done, it's technically out of bullets, and that's how we go into the reloading state. So reloading, it calculates random number between 1 and 4, it's going to delay, and after that, it's going to go ahead and go to root. This is something that we didn't do, which is the practice of once you're done, don't try transitioning to another state, just go straight to root. And this only really works because, again, attacking is the topmost state. It is the most important state in that order. Excuse me. If no line of sight was at the top, we'd have to use direct transitions. And you can kind of see what's, sorry, if no line of sight was at the top and we wanted to go back into attacking, we'd have to use direct transition to attacking. You can kind of see that's happening right here. So after shooting, we can't actually, once state's completed, or if we have no line of sight, we can't go back to root and have this root check in order because no line of sight is on the bottom. We instead have to directly transition to no line of sight because it's never going to pick the no line of sight if no line of sight is on the bottom. Does that make sense? The order here matters very much because the root, again, is trying to select these children in order. And so if you want to automatically go to a state that's above you, you can just go to the root and have it go down from the root, or have the root basically select the children in order. Or if you are trying to go to a state underneath you, generally you need to have some sort of direct transition to it, unless you can basically make your parent state non-accessible via an enter condition. None of these ways of transitioning are wrong. That's something that I want to keep repeatedly stressing over and over again. None of these ways of doing this are wrong. Both of these work, and they work well. The only difference is that this is how they have it set up, and whatever works for them, works for them. That's all. Again, you could have always used a state tree event instead of using on-tick transitions, but in their case, on-tick transitions work, and that's really what matters. So here we have investigate location, and again, you can kind of see if we have an investigate location, we're referencing the investigate location here from the global task, and that's the location we're going to. So it's just different ways of doing it. Here we're searching for the enemy, so we find a roam location using an EQS query, and again, here we're actually modifying a parameter, we're moving to that location from the parameter, and then we're waiting there. So it's a very similar thing to what we're doing. They just made their version of it a lot more in-depth and a lot less fallible because of that. Our version is a lot simpler, but again, it still works, and I want to re-emphasize that to say whatever works, it works, right? So we have the pick a patrol point, we have the wait, we have the found player, we have the chase, we have the attack, we have the search last known location, we have moved last known location, we have wait. This works, right? And even in their case, this works. It's whichever one fits your needs the best. So yeah, that's basically all I have for this tutorial series. Again, I want to re-emphasize that there's not really a right or wrong way to do any of this. It's whatever works and whatever is as optimized as you need it to be. I think a lot of people get too into the weeds on what's optimized and what's not optimized, and the reality situation is, generally, you don't really need to worry about it unless it begins to pollute and unless it begins to actively slow your game down. Now, obviously, before you release, it's a good idea to do checks on optimization, to use the profiler to see how well your game is running. But while you're just developing, while you're prototyping especially, I would not worry about optimization from the get-go. And yeah, so that'll be it, guys. Hope you guys learned something. And if you did, awesome. And yeah, have a good one.